Hello guys, welcome back. So today we are going to be working on chapter 11.1 and this is just a little overview of what we're going to be working with today. So we're going to be starting with the circumference and the arc length of a circle, and our three goals here are as follows. So the first goal is to use the formula for the circumference. The second one is to use an arc length to find the measures, and then the third is to find the measure angles in radians and not degrees. We'll be able to work with both of them, but the main focus is working with measuring angles in degrees. Okay, so this is just a little overview of what we're going to be getting ourselves into. So we're going to start off with this booklet that I have made for you guys. It's a little foldable page booklet that has the definitions and the formulas that we're going to be using, as well as a quick illustration that explains what it is that each academic vocabulary or each term what each term is saying. And then as you open the page, we're going to be working with two examples for each one. Okay, so the very first one that we're going to be working with is the circumference, and the circumference is the distance around the circle. So here I have a circle, and I have the center of the circle. This is the diameter, which is it's twice as long as the radius. It goes, again, we've covered all of these terminology, so we should be familiar with these. And so there are two ways to find the circumference. We can either multiply pi times d, or we can multiply 2 times pi times r, because we know that the radius is half of the diameter. Okay, so that's what we're going to be doing for this one. For the next one, it's the arc length, and the arc length is a portion of the circumference of a circle. Now this one is really important because it's something that we have covered in chapter 10, but in chapter 10 we were trying to find the arc measure, whereas now we are being asked to find the arc length, which again is just a portion of the circle, the portion of the circumference of a circle. So in this case, we would be finding the arc length of AB by multiplying, this is actually the formula, so it's 2 pi r times the measurement of the arc AB over 360. Okay, and then we're finally moving on to the radian, and the radian can be thought of as the length of the arc associated with the angle. So if we're trying to go from degrees to radians, we're going to be multiplying it by 2 pi over 360. But if we're trying to go from radians to degrees, then we would multiply it by the opposite. So it'd be the reciprocal of that. So in this case, it would be 360 over 2 pi. Okay. So these are the main three things that we're going to be working with today. So as we go ahead and open the flap for the very first example, it tells us, so this is what it's giving us. It says, find the circumference of a circle with a radius of 9 centimeters. So again, we know that the circumference is 2 pi r. So now we're just going to go ahead and substitute that in for our variables. So 2 pi times 9, 18 pi. And then in the book, they actually have it, they gave it to you as a decimal form, so they have you multiplying the 18 times the pi. But you can also just leave it the way it is. But we'll just go ahead and, if you were to go ahead and put this in your calculator, you would get an estimate of 56.55. And then it would be in this unit, so centimeters. And that would be your circumference for that circle. Okay, so not too bad. So now let's go ahead and go to the next example. So for this one, it's saying to find the radius of a circle with a circumference of 26 meters. So we're going to be doing the same thing. So we have circumference equals 2 pi r. Now in this case, they gave us the circumference, so we're going to go ahead and just plug that in here. So C equals 26, 2 pi r. We're going to go ahead and divide both sides by 2r to isolate the r. Or sorry, 2 pi to isolate the r. This cancels, and then we are left with 13 over pi. And then when you put this one in your calculator, you're going to get round to the nearest hundreds, and you're going to get r is about 4.14. And since we are dealing with meters, it's going to be meters. So it's very important to always make sure that you're looking at the information that you're given and make sure that you're also using the correct units. Alright, so now we're going to go ahead and move on to the next portion. This was the arc length. Again, the arc length is the portion of the circumference of a circle. So we are using the measurement of the arc, but that's only a portion of how to find the arc length of the entire circle. We'd have to go ahead and multiply by 2 pi r over 360 because we're it's a portion of the whole circle. Okay. So now let's go ahead and open this one up. And this one says to find the arc length of AB. So again, we're going to go ahead and be using our formula here. So we know that the formula is going to be the measurement of the measurement of AB times 2 pi r over 360. And you're going to go ahead and plug in what we know. So the measurement of AB is, in this case, it's 60 times 2 pi, the radius is 8 over 360. Then I'm gonna go ahead and plug all of this into my calculator, and I get about 8.38. And since we're dealing with centimeters in this case, our answer is going to be in centimeters. Okay. So that one wasn't too bad. Again, the main thing is just making sure that you are not forgetting anything in this step. So the very first step is just knowing the correct formula, and that is, again, using the measurement of the arc times the 2 pi r over the 360, because that's the entire thing. It's in relation to the entire circumference. And again, since we're only looking at a portion of that, we need to also multiply it by the 2 pi r. Okay, so now let's go ahead and go to the next one. So this one is finding the measurement of the arc RS. So we're going to be doing the same thing. So let's go ahead and do that. So the measurement of arc. So we're going to go ahead and do same thing. So measurement of RS times 2 pi r over 360. And then I'm going to go ahead and plug everything in. Okay, so in this case, actually, so I have the original formula. It's the measurement of arc RS equals to this is all equal to the arc length of the arc RS. But now again, it's a little bit different because we are going to be looking for this portion. So instead, we're going to go ahead and multiply by the reciprocal of this, just so that we isolate the portion that we're looking for. So we want this on by itself. So when we do that, we have measurement of RS. It's going to be equal to the arc length RS. It's going to be all of this. Actually, you know what? Let's just go ahead and do it step by step. Okay. Let's go ahead and redo this one. So we have the arc length of RS equals to the measurement of arc RS over 360 over 2 pi r. And now we're going to go ahead and just plug in what we know. So for the arc length of RS, that is our 44. So I'm going to go ahead and do 44 over 2 pi r. The radius in this case is 15.28 equals to the measurement arc of, actually what I'm going to do now is I'm just going to go ahead and multiply both sides by 360 so I can isolate that. So I'm going to go ahead and just do that now. And that way I'm just left with the measurement of RS, which is what I wanted. And when I go ahead and plug all of this stuff into my calculator, I'm going to go ahead and just round to the nearest whole degree. And I get 165. Okay. So again, the main thing is just being able to manipulate what we started off with. So in this case, it was the arc length of AB equals the measurement of arc AB over 360 times 2r. Well, in this case, we had it the other way around because we wanted to solve for this. So we would have just divided both sides by 2 pi r and then multiplied by 360, which is what we did. Okay. All right, and so finally we are on our very last one, and this one is the radian. So the radian can be thought of as a length of the arc associated with the angle. So again, in order to go from degree to radians, we're going to be multiplying it by 2 pi over 360. So this one, it says convert 45 degrees to radians. So I'm going to go ahead and actually multiply it by 2 pi over 360, or I can reduce it and it's going to be pi over 180. So let's do that. Let's just, since we prefer to be working with smaller numbers. So 45 times pi over 180 is going to equal to pi over 4. And whenever we're working with these radians, we're just going to go ahead and leave them as they are. We're not going to try and have a simplified answer. Okay? All right, so finally the last one. Convert 3 pi over 2 radians to degrees. So in this case, we're going to be working backwards. So here, our original, method of doing it is multiplying by 360 over 2 pi. Well, I want to work with smaller numbers, so I'll just do 2 pi over 360. Sorry, pi over 180. So times pi over 180. When I simplify these, okay, because this becomes a 60. And then I'm going to go ahead and plug all of this into my, actually, sorry, it should be the other way. It should be 180 over pi times 180 over pi. That could have been a very big mistake. There you go. Then these two cancel, and then I'd be left with 270 degrees. Okay, so we're gonna go ahead and stop right here, and then we're gonna move on with our exit ticket for today.